it's hard to imagine. 72 quintillion of them fit into a single grain of sand. Finding out what an atom was made of led to our next great discovery. To get the story, I went to Fermilab outside Chicago and met with physicist John Wormersley.
Even 100 years ago, people knew how big the atom was, and they thought that electrons and protons would be spread pretty much uniformly throughout the atom. And they called this the plum pudding model because they thought of the electrons like raisins in a fruitcake, spread throughout the inside of the fruitcake.
In the early 1900s, physicist Ernest Rutherford conducted an experiment to further explore the structure of the atom. He shot radioactive alpha particles at a sheet of gold foil.
And he wanted to see what would happen when the alpha particles hit the gold. He didn't expect very much would happen. He thought most of the alpha particles would carry straight on through without being deflected, without being bent through any large angle. But what happened? Well, he found something completely different. He said it was as surprising as if you shot a 15-inch artillery shell at a piece of tissue paper and had the artillery shell bounce back at you. Some of these alpha particles bounce straight back off the gold foil. So the only way this could happen is if inside the atom is a very small, dense concentration of matter. It's not spread out like the plum pudding. And Rutherford called this small, dense concentration the nucleus. What we're doing here at Fermilab is the descendant of that experiment. We take a beam of protons and collide it with a beam of antiprotons to see what the protons are made of.
Thanks to Rutherford's discovery, scientists now knew that the structure of the atom included protons, electrons, and a nucleus. But it was up to James Chadwick, a student of Rutherford's, to complete the picture with the discovery of the neutron.
So we're standing now inside the D0 detector, which is one of the particle detectors in the Fermilab Collider. That pipe there is where the protons and antiprotons actually circulate. And they come into collision a few feet to your right, and all of this instrumentation around it is the equipment that we use to detect the results of those collisions, which kind of takes us back to the history of the neutron. Chadwick was able to carry out an experiment that showed that what the nucleus was made of was protons and neutrons. And what Chadwick used was a clever detection technique, which is what we're standing in the middle of to do that. So he didn't build a big piece of apparatus like this. He used paraffin wax.
Like from a candle?
Like from a candle. And what Chadwick did was to use this wax to intercept those particles that came out of the radioactive process. And then suddenly all the pieces fit into place.
The discovery of the neutron changed history. In 1939, a group of scientists led by physicist Enrico Fermi used the neutron as a bullet to split the atom, giving birth to the nuclear age.